another video tutorial. In this video tutorial we're gonna talk about this exercise, which says one wants to transfer data between two processes. To this aim we use a shared memory segment of size max bytes. When the emitter wants to send n bytes of data, it places them at the beginning of the segment, then sends a message containing n to the receiver through a message queue. When the receiver completes the reception of the message, it sends a message to the emitter to confirm that memory allocation can be for program both processes. So mainly here we're gonna create shared memory segment where we can write data. And then we will have two different processes. I'm gonna call them parent and child process. So between these processes, we will share the length of the data, or number of bytes of the data that's stored in the shared memory segment. So now we can begin to write. Firstly, I have included some useful headers here that we're gonna use during the coding, and then we have defined max as 1024 bytes. Then we have declared message buffer struct, which contains two members, message type and message data. And then message data is type of long because the data that we want to share through message queue is the number of bytes of the data that's stored in a shared memory segment. That's why it's been declared as long. And these are the functions that we will use. Now. Firstly, I want to write main function here. Okay. Now, firstly, I want to begin with remove IPC. So here in this function, after everything is finished, we're gonna remove the message queues that we have created and the shared memory segment as well. So that's why I'm gonna pass 3 arguments, and if first I'm checking that everything is correct with the message queue, then that I can delete it, remove it with message ID 1 and IPC RMID, and I don't use this struct. So if a message, there is a queue which has this ID, so I want to remove it, and I just gonna copy this one for the message ID 2 as well. It's gonna be the same. So if there is another message queue, I can remove it, and then if SHM ID is equal to -1, I can remove it as well, but I'm going to use different function, which is SHM CTL control. SHM first parameter is SHM ID, and IPC remove, and I don't use this struct neither, so no. Yeah, so everything is finished. I will use this function to remove everything. Then I want to begin with readline function, which we have seen before in this in the previous video tutorial. So in this function mainly reads from the standard input and returns us the value that then we will use this value in another function to check if it's end of the file or not. So here if f gets I'm gonna get something from the input and put it in the text, and bytes std in. If it is equal to null, then I'm gonna set r as e of. Else I'm gonna set length is equal to length of the text that's been entered, and I check if length is greater than 0 and text length -1, and the last character of the text is equal to a new line character, then it means I can say that this is the end of the string. To this purpose, I'm gonna set it to \0, and in this case, error is equal not EOF. In another word, it's equal to 0. EOF has been declared as -1 in the standard input-output header. So in this case, I set R to 0. Otherwise, R is a garbage value. We don't know. In the beginning, we haven't initialized it. So now I want to return R. Then I first want to begin with writer function. Here, writer function is gonna write number of bytes. I just gonna call it bytes, number of bytes as well, to the message queue. But how it's gonna write? Firstly, I am declaring struct message buffer here, and I set a message type to 1, and I set message data to the number of bytes that I'm gonna pass as the parameter here, and then I am passing the I'm sending to the queue message ID, struct pointer to the struct that I'm gonna use. Here I'm sending number of bytes to the message ID, and if I don't use flag, so I ignore it as with 0. So if it's equal to -1, then there is something with message send, and I exit with exit fail status. And this is the writer function. Writer function just is gonna write to the message queue, and for the reader function, I'm gonna write it as here. Read from the message queue, and here I just want to declare it as data. Now I will explain you what we will do with this data parameter. So firstly, I'm gonna use message buffer struct here. So a reader function just received message from the queue, and as a message size, I just gonna declare it max, and 0 message type, message flag is 0. If it's equal to -1, then there is something wrong with message receive function, and I exit with exit fail, or I can write exit 1 as well. And then I just write data is equal to n.message data. Here it means that this line means that the address that this data points to is gonna hold the data that's stored in MSG data. Or in another word, I can say that message data will be assigned to, if I can say that, yeah, it will be assigned to the address that data points to. Okay, so why we use this? Because then in the parent, in the child process, I want to read from the read from the message queue, where it stores the length of the data that's stored in shared memory. So I will use one parameter to get the length that's stored in the message queue. That's why I'm using this parameter here. And now you will see, I hope it will be clear for you. Then as the next part, I want to continue with the parent process. We have finished these 4 functions, and then I want to continue with parent process. Here, parent process is gonna write into the first message queue, read from the second message queues, because the child function is gonna send something to the message queue, second message queue. That means that it has finished reading, and a message queue can be freed. And I'm using SHM address. Here you can ask, why are we using char pointer? Because mainly, yeah, you can see that it's written as void. If you're using void pointer, it means that the address that it points to, the address that the variable points to, in this address you can hold any variable, I mean any data type, any type of variable. So if you're using void pointer, it means that you can store their character, you can store their integer, float, double, whatever data type that you know. But if you specify it as char pointer, it means that you can store their only character. So here in our exercise, in our task, we're going to store only character. That's why I'm using character pointer to character. So the parent process firstly is going to read, and here as a first parameter I'm going to pass SHM address, because I want to store whatever the user has entered from the standard input in the SHM address, and the number of bytes I'm going to pass as maximum. Why it is unequal to E of? Firstly, I will just put writing to the queue, just writing to queue, and I'm gonna call writer function here, which takes first parameter as a message ID. So I'm writing to the first message queue, and then what I want to write is the length of the data that's stored in the SHM address, right? So I'm just gonna write string length SHM address. So this way I wrote the length, the number of bytes in the message queue, and then I put here reading, and then it reads from the second message queue, and here as a parameter I'm just going to declare data. Here this parameter is not needed. I need to pass something, that's why I have declared the parameter. So it will read from the message second message ID, while it's not EOF. And if it is EOF, it's end of the file. I just want to, the parent function is gonna free the message queue that's it's been writing something. Okay. Then I'm coming to the child process. So I just need to copy this one from here. Okay. Here it has the same parameters. I'm gonna copy and paste it here. Okay. Here the child process should get the length. So as I said, I'm gonna take it with reader function. So first I just gonna declare length variable here, and then child process begins to read from the first message queue, and in the first message queue we have stored the length of the data. So I'm gonna write length here. As you see here, reader function is gonna store the data in here points to the length the address of the length, and in that address we will assign the message data in the message queue. So, and it is the length of the here you see it is the length of the data that's stored in this SHM address. So it reads, and if length is greater than 0, I want to first I want to print the data stored in shared memory. So it is string. It is string, and it is SHM address. And then I want to print the data received from queue, and its type is long, so LD, and it is length. And then after reading, I just gonna send 0 bytes to the second queue, so that it means that I have finished reading, and then the parent process can also free the message queue. So we have done all the functions that we have here. Now we need to call them in the main function. Here, firstly, we have message ID, IDs, and shared memory ID as well. And to get message ID, we are using message get function. As a first parameter, IPC private, and as a flag, I'm gonna pass the permissions. For the second queue as well, to get the ID for the queue, I'm gonna use the same stuff. I pass the read-write permissions, and for the SH shared memory ID, I'm gonna use different function, which is shared memory SHM get. Here as a key, I pass IPC private. As a size, here it's as it says the memory segment of size maximum bytes, so I'm gonna pass max. And as a flag again, I set permissions. After that, we need to attach to the memory address. With the help of the SHM at function, and the first parameter is SHM ID, and as an address, I'm gonna pass null here, because so that I say that the computer that's to set any suitable memory address to my shared memory segment. And I think we have finished about it. And then after that, I need to check if everything is okay with them or not. If message ID 1 is equal to a -1, or message ID 2 is equal to -1, then it means there is something wrong with message get function, and I exit with exit failure. And if shared memory ID is equal to -1, and then there is something wrong with shared memory get function, and I exit with exit failure. And then we should fork, so that we have two processes. I just write switch fork. Here, in case -1, it is it means that there's something wrong with fork, and I exit with exit failure. case 0, it means this is the child process, so I'm gonna call child process, which takes message ID 1, message ID 2, and SHM address. And then it exits with exit success status, and in case not in case, but by default it's parent. So in the parent process, I'm gonna call a parent function, pass the arguments, message IDs, and SHM address, and I'm gonna exit with exit success as well. Yes. And after everything finish, I can write remove IPC, message ID 1, message ID 2, and SHM ID. Yeah, I think everything is done. Now we can run and see if there's problem. Okay, so we sent some data. Let's say hello. Okay, here you see, as you see, in the parent function, writing Q to Q. It writes and reading, and then it says the data stored in the shared memory, which is hello, and the data received from Q is the length, which is the length of the data that's stored in the SHM address. And now I press Ctrl D, I send EOF, that it terminates. Yeah, this is all about this exercise, about this task. If you have any question, feel free to ask. And about the source code, we will try to solve it. We will either place the source code in the Moodle or in the GitHub. We will let you know. Okay, see you in the next tutorial. Bye bye.